Alright. Now, looking at the rectangle, what can we say the area of the left-hand side is? If one side is 3 and the bottom is 6, what's the area of that rectangle?
18.
18, good. Because we get 3 times 6, and if you wanted to, you can count all those little squares. But we know from our maths in junior school that that is 18. Alright, now you'll notice that the rectangle on the right is the same, except I put a little dividing line in it. This is still 3 in length. However, the bottom one I've split into 4 and 2. Yeah? 4 blocks and 2 blocks. So, what would just this area be? Yeah? 12? We can count them if we want, but we can get that area by doing 4 times 3. And what about the rectangle on the right? The 6. And we get it from 3 times 2 equals 6. And if we add the areas together, we still get a total of 18. Which is what we'd expect, because it's the same size rectangle. We've just split that 6 into 4 and 2. Okay. So if we were going to write out that rectangle in sort of a math sentence, we could say that it was 3 lots of 4 plus 2. Because this line here is 4 plus 2. Okay? And then to work out the area of that multiplication, we have done 4 lots of 3, or 3 lots of 4, so 3 times 4. And then we've added on the second miniature rectangle, which is plus 3 times 2. So the 4 and the 4, the 2 and the 2, and the 3 appears twice because we're multiplying each of the rectangles share that common side of 3. Okay? And is this looking similar to what we did yesterday, in that the 3 is multiplying into both the 4 and the 2? Okay? But you can see how the right-hand rectangle is equal in size to the left-hand rectangle, even though we've done the math slightly differently. Yeah? We're getting the same answer, it's still going to be 18. Okay? Now we can use this same pattern with algebra. So, do you want to draw another rectangle underneath and divide it again in 2? This time our sides are going to be 4, and of course we eventually have to throw numbers in there somewhere, so let's call this bottom one 2a, and then this little one 3.
Just ask. Can you scroll up to the previous one because I'm kind of working.
That one?
Yes.
Yeah. Do tell me to slow down if you need. Can I go down a little, Demir?
Yes, I was good.
All good? Alright. So with that little box I have highlighted around the corners in green, what would its area be? If up here we found the area of that rectangle by doing 3 times 6, or length times width, how do we find the area down here? Yep.
4 times 2.
4 times 2a, because we have to take the whole side. The whole side is 2a. So we find this by saying 4 times 2a. And from multiplying algebraic terms in the last topic, what does we get? What do we get?
8.
8a, because 4 times 2 is 8, and the a stays there, so that is 8a. That's okay? What about the other box? The one that we haven't coloured? Yeah? 4 times 3 is 12. Alright? Now, if we're going to write this in a math sentence rather than drawing a box, it would look like this. It would be 4 times 2a plus 3, because that bottom length is 2a plus 3. Right. And our working, which we've shown inside the rectangles, would be 4 lots of 2a plus 4 lots of 3, giving us a total of 8a plus 12. Who likes the rectangle way of thinking better than the fruit basket way yesterday? Easier, sort of?
Rectangle.
Well, you weren't even here yesterday, buddy. Okay, so you definitely like it better. That's good. Alright, I'm going to draw measurements for this one, and then I'd like you to have a go at it by yourselves.
Why is it really big?
Let's make that side 2a. Three, and we'll go an x. Alright, same working as before. Try and work out what each little section is of the rectangle, and then do the maths underneath. Yeah?
Just saying, are we just supposed to do 3 for it, or because...
Yeah. For this bit here,
Yes.
what's the two sides?
Well, I know.
2a
Yes.
and 3. So if we do length times width,
No, I mean as in, because it looks like 3, the side, and it looks like 4, the...
oh, don't worry about the scale and the squares. Because now we're in algebra, we don't know what the x's and the a's are. And the 3 I know isn't quite 3.
No, it's how the square stuff. That makes it look like it's another number.
It does.
Yes, that's what. So what am I supposed to do? The 3 or the 2?
3 times the 2a.
No,
It
the
means
shape.
lines going down the middle of the square.
Yeah.
Oh, right.
2 or 3?
It doesn't matter. Here, let me see what you've drawn.
I'm drawing anything yet.
You can go down the middle, it's fine. Tell you what, to help you. There. No more grid.
I mean, it's still supposed to be 2, yes.
Alright, so for this rectangle, what do we get?
6. 8.
6a. And that came from 2a times 3, which is 6a. And then this one here, the other one, yeah?
2ax.
Good, 2ax, because it's 2a times x, running out of space, which abbreviates to 2ax. Our total then would look like this: 2a bracket 3 plus x, leaving us to 2a times 3 plus 2a times x, 6a plus 2ax. Okay. And these are similar to the ones you guys will have to shot at for homework, or will have had a shot at last night for homework. So let's make it a little more difficult. Sorry, did you want me to go up? Was that too fast? Alright, I'll go up. Alright, look at this one on the left here. Now there are two parts to it. The first part is the 5 multiplied by the bracket, and that will be similar working to what we just saw. And then there's a minus 4a on the outside. Now, from BEDMAS, brackets, exponents, etc., division, multiplication, addition, subtraction, we do the addition and subtraction last. So we can leave this minus 4a term till right at the end. We have to do the brackets first, and then multiplication. Now, inside the brackets, 3 plus a, we can't really simplify that. They're not common terms, we can't add them together. So our next step is to multiply. And if we multiply 5 lots of 3 plus a, what's our first step? Yeah? Bodhi, have a shot? No? Not scratching your head?
No, I don't know.
Huh?
5 times 3.
Good. So that is 5 times 3. Next one.
5 times a.
Good. So the 5 goes to both. Plus 5 times a. And remember, there's still a minus 4a on the back. Okay. Now, 5 times 3 will be known as 15. Plus 5a. 5 times a. How do we write 5 times a?
5A.
5a. Plus 5a. And there's a minus 4a on the back. Now, can we make that look any simpler?
20A.
Careful, they're not multiplied. If it was 5a times 4a, you're right, it would be a 20. But it's not, there's a subtraction between them. Cassie? Not Cassie, sorry. You know what I meant, Claudia.
Is it 15 plus 1a?
Good. How'd you get the plus 1a?
Because 5 take 4 1.
Yeah, they're like terms. So there's 5 lots of a minus 4 lots of a. You can think about it as 5 apples take 4 apples.
So we're supposed to be writing this.
Yeah, the notes would be good.
So was it 1a?
1a, because it's 5 minus 4. So it'll be plus 1 lot of a.
Yes.
Yes? Yeah?
Yes.
If you're happy in following the logic, then you'll be okay. Because we'll do practice on these in a session. The important thing is to follow it through. Alright. Take a look at the right hand one. Now here, there are really 2 multiply signs, aren't there? We just can't see them. There's a multiply between the 2 in the bracket, and there's a multiply between the 3 in the bracket. We have to do those multiplications first before we try that addition in front of the 3. Alright? So just taking the left hand side. Yes, Demir?
First you do 2 times 3x.
2 times 3x, which is
6x.
good. 3x, which is 6x. And then what's next?
2 times 1.
Lovely. 2 times 1. So that's plus 2 times 1. And then plus, good, 3 times x. Speak up.
Take 3 times 3.
Good. Why the take?
Because it's a bit take in the brackets.
Yes, that little take there is important. So when we do the 3 times minus b, it would look like this. It would look like plus 3 times minus b. And then when we simplify it for our next line, we have that going to there, that going to here. Then 3 times x is plus 3x. And our last one here, 3 times minus b is... Yeah, buddy?
Isn't that a positive or negative? Because they're
Negative.
different.
Yeah, the signs are different, so it's negative. So we've got a positive 3 and a negative b. So we're going to make a minus 3b. That will come to there. Now, look at that bottom line. Are there any similar terms? We've got a 6a, a 2, a 3x, sorry, a 6x, a 2, a 3x, and a minus 3b. Yeah?
The 6x and 3x.
Good. The x's are like. So how do we simplify them? Ready?
Oh, I was going to say that's 2 3s as well.
You're right, there are 2 3s, but remember it's the variable or the letter that makes things like. So the letter must be the same. And the powers of the letter must be the same. So we've got a 6x and a plus 3x, which gives us positive 9x. Then the others come down, plus 2 minus 3b. Alright. And that is as far as we can go because we don't have any more like terms and there's no more multipliers. What I'd like you to do now for the remainder of the lesson is to look at that. We started yesterday, but questions 3 to, let me see, you guys really should be able to get to 7. Green 3 to 7. Green, so you won't have to do them all. And I'll leave that working on the board for you. If you don't have a book, I'll come around and help you in a second.